Here the answers are on there, but I know this is sometimes helpful too. So the first one, the main idea that I want to get across is you are looking for the true population proportion. That's the phrase we write. The conclusion of every one of those essays we did, that's the kind of the phrase we sum everything up with. So I would want to say, you're 95% confident that the true population proportion of students who support free lunch is between 0.7 and 0.9. This is most likely to be a multiple choice on the test, and you're looking for like this phrase. Instead of population, sometimes they say all. But that's the same idea. Okay, so here's like little notes on the problems on that note. So with the width interval goes down. I'm sorry, as n goes up, width goes down. As n goes down, width goes up. And it doesn't change by the same amount, it changes by the square root of the amount. So like if n gets 4 times bigger, the width of the interval gets 2 times smaller. N gets 9 times smaller, the width gets 3 times bigger. So how am I getting from 4 to 2 and 9 to 3 is I'm taking the square roots. 16 times bigger, margin of error 4 times smaller, n gets 4 times smaller, the margin of error gets 2 times bigger. Here's kind of your next thing to know. As the confidence goes up, the width needs to go up with it. As the confidence goes down, the width goes down with it. So if our confidence goes up from 90 to 99, you're going to go from something like this to something like this. Bigger, wider. So the width goes up, the margin of error goes up. The point estimate is like what's right in the middle. I would say the same. Confidence goes from 95 to 85. So now you're going to have like 95 to 85 is going to get smaller. So the width goes down, the margin of error goes down. The point estimate is what's right in the middle. And that would not change. Again, here's kind of some notes and then a table to make sure you know how to do that stuff. So from 100 to 200, I like sketch like a number line. The width is just how far it is from one endpoint to the other. Part of the point estimate makes sense. The point estimate is the average of these two. It's what's right in the middle. So in this case, that's 150. The margin of error is how far it is from the middle to either endpoint. The plus minus form is okay, we're at 150, and then we get to go 50 either direction to get to our endpoints. So, like in this one, if the point estimate is 15 and the margin of error is 25, that means we start at 15 and we go 25 each way, which would put us between negative 10 and 40. The width is how far apart are these two numbers, so that's 50. This is just another way of saying, like, we start at 15 and we go 25 each way. This means we start at 8 and we go 4 each way. So start at 8 means that's your point estimate. 4 each way, that's your margin of error. So we're going to end up between 4 and 12. And our width is 8. Point of estimate is 1 and the width is 2. So 1 has to be right in the middle. And it has to be 2 units wide. So it must be between 0 and 2. Because this is 2 units wide, and it puts 1 right in the middle of those two numbers. So margin of error is always going to be half the width, and there's your plus minus 1. This margin of error one, where you're finding n, so I kind of do the whole thing on the calculator, but if I start writing notes on here, that's your formula for margin of error. Z star is inverse norm of 1.95 divided by 2. So that's like 1.96. It didn't tell me P, so I don't know P, I use 0.5. And then these two have to add up to 1, so Q is also 0.5. next thing I would do is divide by that 1.96. And then I can multiply those together too. So it's like 125 over n. And then I'll divide those in my calculator. I get like 0.015306. Or you don't want to round, I think it's. Then I would square both sides. So if I square the square root, they just cancel. And if I just go to my calculator and say like to the second, I get 0.00234286. And remember this thing, we can flip flop those. So n is going to equal 0.25 divided by our previous answer. So just like that. So it, I just kept doing answer. So I never rounded. The calculator kept all the actual values in there. That gives me 1067.07, which means I would need to ask 1068 people. Alright, again, here's like some notes, and then I'm asking you a question about it. So it's a reasonable assumption if it's in between the endpoints. Is 0.5 in between those two numbers? Yes, it is. So is the reasonable assumption. Yes, it is. Is 0.25 in between those two numbers? No, it's not. So is the reasonable assumption. No, it's not. If you want to know if two proportions are the same, well, if two proportions are the same, and I subtracted them, think about it, if two proportions were both 0.4, and I did 0.4 minus 0.4, I would get 0. So if they're the same, you're going to have 0 in your interval. So it's not reasonable to assume these two are the same, because 0 is not in it. These I'm not gonna go through with those. That's just that you need to know at this point how to do a 1 and a 2 sample. That's a template sheet, whatever you want to call that. Here I'm gonna go to my calculator and go just kind of skipping through the log writing out process and just doing that. So on one prop, that'd be 38 out of 95. So 0.9. And then I get so I get like 0.3 and 0.5, let's say. Do we have a large enough sample size? Well, we have to make sure we have at least 10 yeses and at least 10 nos. 38 yeses, whatever the difference between those is, so like 57 nos. Those 1, 3, 10. So 2 large enough sample size. Point estimate. So kind of thinking about that chart we did a second ago. Point estimate is what's right in the middle of these two, so you take the average, 0.4. The margin of error is how far it is from the middle to one of the endpoints, 0.1. Width is just how far apart are those, plus minus format. Same idea, but for a 2 prop. So 2 props the interval, 25 out of 60. 15 out of 35, confidence level 0.9. So I get negative 0.18 and 0.16. Do I have a large enough sample size? I do. And the reason is because I have at least 10 failures and successes. So 25 yeses here, 35 no's, 15 yeses here, 20 no's. Those are all bigger than 10, so good. Point estimate is what's right in the middle of these two. So you literally just find an average. So you go like negative 0.18 plus 0.16 divided by 2. So that's negative 0.01. So we've got like negative 0.01, negative 0.18, and 0.16. So this distance here or this distance here is the margin of error. That's 0.17. The width is all of it. 0.34. And the plus 4 minus 4 now would be like start in the middle and tell